Hi everyone, my name is Flanagan. I'm the Group 1 6-minute talk on the Wankel engine. A little introduction to this presentation. I will discuss the Wankel engine and how this internal combustion engine uses an eccentric rotary design to convert pressure into rotating motion. I'll also discuss the success as well as the downfall of the Wankel engine. So, little origin of the Wankel engine. It was the first practical rotary internal combustion engine designed by German inventor Felix Wankel. It was not successfully tested until 1957. It is very compact and smooth during operation, but it is not sufficient to overcome the high manufacturing costs. It also operates at high engine speed, but it's often offset by its high heat transfer and leakage problems. So a little bit about how it works. It consists of two rotating parts, the triangle-shaped rotor and the output shaft with its integral eccentric. The rotor revolves directly on the eccentric and has an internal timing gear that meshes with the fixed timing gear on one side of the housing to maintain the correct phase relationship between the rotor and the eccentric shaft rotations. Thus, the rotor rotates and orbits around the shaft axis. The combustion chamber lies between the center housing and the rotor surface and is sealed by seals at each apex of the rotor and around the perimeters of the rotor sides. As the rotor makes one complete rotation, during which the eccentric shaft rotates through 3 revolutions, each chamber produces 1 power stroke. Here's a little geometry of the Wankel engine. The top figure shows the geometry operates with the 4-stroke cycle and the major components of the engine. Figure B shows the induction, compression, ignition, power, and exhaust processes of the 4-stroke cycle. This figure is a cutaway drawing of the intake port injected 2-rotor automobile Wankel engine. The 2 rotors are out of phase to provide a greater number of torque pulses per shaft revolution. The chamber cut out in each rotor face and the rotor apex and side seals. There are 2 spark plugs per firing chamber, often used to obtain a faster combustion process. And there's a large side intake and exhaust ports, and they're used to increase airflow and improve burn gas outflow. So here's some advantages and disadvantages of the Wankel engine. First, the advantages: it only has 2 moving parts, rotor and axle. The vibrations can pretty much be eliminated with well-balanced counterweights. A comparable piston engine would be 3 times as heavy and 3 times as large, and has smooth power delivery. And rotary engines are unlikely to suffer from the early self-ignition, which is the knocking, and it also has higher revolutions per minute, which are manageable. Some disadvantages: the extreme temperature differences within one chamber lead to short-lived seals, usually less torque than comparable piston engines, and practically shaped ignition section, which leads to poor efficiency. And the multi-rotor engines are prone to heat damage in between the chambers. So the birth of the first rotary car. The first rotary car was the Wankel Spider. It was actually a German car, German manufacturer NSU. Later became part of the well-known car manufacturer Audi. This was the first production car fitted with a rotary engine. It was 700 kilograms. It delivered 37 kilowatts at 6,000 RPMs. To counter the engine's weight, the fuel tank and radiator went up front, leaving 2 tiny luggage compartments. The engine was powerful to push the car 155 kph. There were 5,000 made, 2,375 were sold, and about 2/3 are still around today. Pretty high item for car gurus. So here's the fall of the Wankel engine. Some problems with it: had poor thermal efficiency, poor fuel economy, and consumer resistance. So the poor fuel economy, unlike the reciprocating engines that have highly engineered combustion chambers, the combustion chambers for a rotary engine are long and narrow and move along as the rotor rotates. none of which is conducive to effective combustion. Poor fuel economy, has low mean effective pressure at light engine loads, which require extremely rich air fuel mixtures to keep the rotary engine turning over at low engine speeds. Some consumer resistance, really had some reliability issues. One of the major issues was the oil injection system, which if worked required constant topping off to prevent engine damage. So where is the Flanagan engine today? Most people associate this engine with past vehicles such as the Mazda RX-7 and 8, or Norton rotary motorcycles of the 1980s. But the Flanagan engine is still being used today in snowmobiles, speedboats, airplanes, and even some space vehicle launch systems. So rather than being a failed technology, it's been pretty successful in niche applications. And that's one of the references.